Hello, I am Arundhati Das, and in this lecture, we will talk about the context free grammars. Now, in the formal language theory, a context free language is a language generated by some context free grammar. Here, if we remember, the context free grammar is a type 3 grammar which accepts the context-free languages, and we design the push-down automata for the context-free languages. The set of the context-free languages is identical to the set of all languages accepted by the push-down automata. Now, the context-free grammar have more power than the regular grammar. Why is that? Because in regular languages, it has limited storage. It cannot count the numbers required for the following productions. In this language, we overcome this using the pushdown automata. Now, the context-free grammar is formally defined using the four tuples, which are V, T, P, and S, where the V is non-terminals, T is the terminal symbols, P is the production rules, and S is the starting symbol. The production rule has a the CFG has a production rule of the form A gives alpha, where the alpha is the union of the non-terminals or the terminals, and here we can see there is a closure, which means it includes the epsilon also, which means the empty symbol, and the A belongs to the non-terminals. For example, a language that generates equal number of A's and B's in the form A raised to the power n and B raised to the power n. Here we can see that this language is not regular, because in regular languages we cannot store anything. Here, if we try to design a finite state machine, we won't be able to do it, because the number of A should be equal to the number of B's, in which means we have to count the number of A's, then we can give the number of B's. So we will use the context-free grammar to produce this output. So the grammar will be G equal to S and A, which are non-terminals, A and B, which are terminals, and this production rule and the starting symbol as A. Now let's look at this production rule. This production rule says that S gives A, capital A, and B, and the A gives A, capital A, and B, or the A also gives the empty symbol, which means nothing. So let's start. Here we'll start from the S. S is the starting symbol. So it gives A, capital A, and B. Here we can see that A is the non-terminal. So we will replace it with the production rule of A. So after replacing A with A, capital A, and B, we get this. Here we can see that the number of A's and B's is equal. Now we can terminate this A, or we can stop this production symbol by replacing the A with the epsilon. So here we replace the A with epsilon, so it gives AA and BB. So we can see that the number of A's and the B's in this language is equal. We can further do it by replacing this A again with A, and B. It will again give the number of A's will be A, and B, which will be equal. So this is how the context-free grammar works, and the context-free grammar is more powerful than the regular grammar. Thank you.